Welcome to Maths on Radio, a program catalyzed and supported by National Council for Science and Technology Communication, Department of Science and Technology, New Delhi.
सोचो, सीखो, बोलो, बदलो। सोचो, सीखो, बोलो, बदलो, चमका दो दुनिया को, जीत लो इस जहां को।
सोचो, सीखो, बोलो, बदलो, सिर्फ मैथ्स ऑन रेडियो के साथ 107.8 FM मस्ट रेडियो पर।
प्रफुल, वो वाइडी मेलिसा जेके को मैथ पढ़ा रही है। मुझे तो मैथ का मतलब भी नहीं पता। प्रफुल, मैथ मतलब?
मैथ हंसा, वो मेरे ऑफिस के शिंदे भाव की बीवी शिंदे भाव के शर्ट का बटन टूटने पे क्या बोलती है?
वो तो ऐसे कहती है, ओ बाबा तुम्ही ना थांबा, मी आत येऊन लावते। मियात, ओ बाबा मियात। अब प्रफुल और हंसा को मैथ सिखाना हमारे बस की बात नहीं, पर आप सब लोगों के लिए हम ला रहे हैं सुबह 9 बजे, दोपहर 1 बजे एंड शाम को 7 बजे मैथ्स ऑन रेडियो। सुनते रहिए मस्त रेडियो 107.8। Hello listeners, you are listening to 107.8 FM Mast Radio, where you get your daily dose of infotainment. This is our Math on Radio show, Season 2. And I'm RJ Priyal. Today on our Math on Radio show, we'll talk about derivatives. Derivatives of first order, second order and third order. डरने की जरूरत नहीं है, इसे हम डेली लाइफ में कैसे यूज करेंगे ये भी बताएंगे। मैथ और टेक्नोलॉजी का इस्तेमाल करते हुए हम कैसे बहुत सारे सोशल काम भी कर सकते हैं, ये भी सुनेंगे हम आज 107.8 FM मस्त रेडियो के शो मैथ ऑन रेडियो सीजन 2 पे।
बॉल रन चाहिए 4, मैथ्स बिना कैसी जीत कैसी है हार। 1 किलो चावल में आधी किलो दाल, खिचड़ी में भी मैथ्स चाहिए यार। मैथ्स बिना दुनिया में कुछ भी नहीं, जहाँ जाए नजर दिखे मैथ्स ही वही। जिंदगी में मैथ्स बिना कुछ भी नहीं, और मैथ्स बिना किक मुझे मिलती नहीं। मैथ्स बिना किक मुझे मिलती नहीं, हाय मैथ्स बिना किक मुझे मिलती नहीं। मैथ्स बिना मैनू मैथ्स ना मिले तो मर जावा। मैनू मैथ्स ना मिले तो मर जावा।
फिर से मैथ्स में 0। हे भगवान, कब बनेगी तू मैथ्स का हीरो? क्या करूं मैं इस लड़की का?
अरे ट्यूटोरियल ज्वाइन करवा दो।
अरे नहीं, एजुकेशनल क्लासेस।
नहीं, प्रीति मैम की नोट से ही पढ़ लो।
नो मॉम, अब मैं करूंगी मैथ्स में टॉप और उड़ाऊंगी आपके होश, क्योंकि बढ़ रहा है मेरा जोश। अब नहीं देंगे हम मैथ्स टीचर को दोष, बिकॉज मैथ्स ऑन रेडियो हर रोज सिर्फ और सिर्फ 107.8 मस्त FM पर सुबह 9 बजे, दोपहर 1 बजे और शाम 7 बजे। friends, most children study math in school. But what about those students who don't go to school, who skip school, who are kidnapped or are lost? There are a lot of measures taken to track those lost children. Anti-human trafficking commissions are always on their guard. Today we are going to talk about one such initiative called the Helping Faceless Project. They are trying to combat child trafficking with the use of technology and mathematics. So friends, this project, Helping Faceless, is an Android application devised by two IITians, Shashank Singh and Amol Gupta. In fact, Shashank Singh was just saved from being kidnapped and becoming one such lost child. Now he has devised this Android application with the help of technology and mathematics to help combat child trafficking.
Yeah, hi Shashank.
Hi.
Yes, we heard that you run a NGO called Helping Faceless.
Yeah.
Yeah. So could you tell us about it, and also, what exactly this project is all about?
Okay. So, well, it's not an NGO as such. It's an initiative by us, more of an initiative. In early 90s, there was an attempt made to kidnap me when I was a kid, and that has always been at back of my mind. I wanted to do something about this, and I did a lot of research, and what I found out was that every 8 minutes a child goes missing in India, and around 80% of those cases are never solved. So I always wanted to do something, and my personal experience was always back of my mind. So last year, when I was talking to my friend Amol Gupta, we came up with this idea of using technology, which is our strong suit, to help these children. US has an infrastructure to help missing children. It's called Project Amber. India, I think even Canada has one. All the developed nations have some sort of version. India doesn't have anything like that, even though we have so much trafficking going on, human trafficking going on. So the idea was to take pictures of missing children. We get this from National Database of Missing Children. There's a Government of India publishes children that have gone missing in past few years, and they publish on a website. It's publicly accessible data, and they publish whatever data they have: name, gender, location, they was last seen, birthplace, and everything, birthmark and everything, with a photograph. So there are around 80,000 to 90,000 photographs there. And even every state police publishes its own database of photographs of database of missing children. So what we do is we source data from these places.
Okay.
And then we have an app where people can upload photographs of children they see in distress. Once that photograph is uploaded, is matched to all the 60,000, 80,000 photographs we have, roughly 80,000 photographs we have, and a similarity matrix is created, because face recognition doesn't, unlike TV, face recognition doesn't tell you who looks similar. It gives you a fraction. It gives you like these two photographs are 0.67% 0.67 similarity, have similarity.
Okay.
This one has this, and there is confidence level that you can't. If a photograph is matched, let's say 100, it's matched by 100%. Let's talk in percentage. So, if your algorithm is saying it's matching 100%, then certainly there's some error. It shouldn't be matching so much. So that sort of there are limitations to face recognition, and you have to tiptoe around them. So what we do is we create a matrix, a giant matrix of who, or rather a social network, if you will. It's like a social network. Which photograph has what sort of relationship with another photograph?
Okay.
Right. It's like your or my face might match, say 10%. 10%. That 10% will show what sort of similarity they maintain. And from that sort of similarity, we try to figure out which we do clustering over it. There's an algorithm called K-means. We use this algorithm to do clustering of similar things. So we use this algorithm called K-means and to figure out which photographs belong to the same person.
Okay.
Out of this giant matrix or graph, we figure out which photographs pertain to the same person, and then we take it, feed it back to the people to the same app we have, and increase the confidence level by showing them that ये जो आप photograph देख रहे हैं are these of the same people, because algorithms are always not correct, as I said.
Correct.
The accuracy is around 60 to 70%. And so then humans are the best face recognizer that we have with us. So we send this data back to people saying, yeah, probably same people. If they say yes, the confidence, our confidence in that is, then we tell our algorithm to work better next time, essentially.
Well, of course, it's all about mathematics being used better and better, or technology used better and better. What has been the success rate? How many cases sort of have you all been able to help with?
It's a recent initiative, and we are still bootstrapping. We have been able to help around 3 children, directly or indirectly. The thing is, we work with a lot of organizations, and we don't specifically do child rehabilitation ourselves.
Okay.
Especially, we don't have experience in that. So we work with another organizations which take on from there on.
Right. And how about you were working on also trying to trace the probable route of trafficking?
Yeah. So the thing is, once we have enough data, let's say 3-4 years down the line, we have enough data. What we can do is we can predict crime. In essence, that trafficking is a unique crime. It happens at a long duration, let's say a week or 3 days or something like that. Like crime of passion, it has a long duration where you can interrupt and foil the whole plan. Right? There's a supply where if you look at it as a business, there's a supply where the humans, whatever. I'm talking about third person, but
correct.
Yeah. So they have to be taken, and then there's a whole logistics how they travel, and then there's a destination where they reach. Right. So there's a whole elongated plan. So if we can predict which route they're going to take or which destination are they going to reach, we can foil their plans. We can foil the traffickers' plans. So the idea is to there's this. You might have heard the term big data analytics.
Yes.
It's essentially we use the same algorithms. What we try to predict is using Bayesian probability, that what is the probability of this event happening if this event has already happened at these time durations.
Okay.
So time durations have like if you chart it on a graph on a time series, let's say 2 baje hua, 3 baje hua, 4 baje hua event, and then next day 2 baje hua, 3 baje hua, the next day 2 baje hua. So what's the probability of happening at 2? By these 3 data, I can tell कि 2 baje hona chahiye probably. There's, let's say, 80% probability. That sort of thing.
Correct.
So we have time, and if we have time, and if we have event, like we know the event, then we can predict when the event will happen again. So we need lot of data for that. So what we do is so the missing children are generally trafficked. I mean, some of them run away, obviously. But our assumption is, or rather from the stats at least, from the NCRB stats, National Crime Stats, around 60-70% of these children are trafficked.
Okay.
So, assuming that, what we do is we take the place they went missing from, the time they went missing from, and when they reappeared, like they were found somewhere else. Right. So we try answering the root question, like this is the lat long they went missing from, and this is lat long they reappeared. And if we have enough data from both ends, we can try figuring out the route, or at least the time taken.
Time at least, which will be in fact a great help in the situation whatever we have now.
Yeah.
Absolutely.
So there's another side to the story also. Not only on that end, but all these trafficking rings or the begging rings have a certain business model, right? You'll always see a child sitting next to a maternity hospital.
Okay.
Right. This sort of things have certain sellability, if you will. It's a very crude term, but sorry, I have to use it.
Yeah.
Certain people have certain sellability. So jiska haath toota hua hai, handicapped hai, and if he's a kid, you will generally find them near child hospitals because they evoke that sort of emotion, and people are more prone to give money to them.
Correct.
Right. So they understand the sellability, and so that's why these people are rotated. Even though they are rotated every week or 2 weeks, they haunt the same places. They are rotated on the same places. Like if they are 10 children, let's say there are 10 children hospitals, so they'll be rotated in these 10.
Okay.
So if we can, using our data, we can predict where they'll go next.
We can probably find them.
Yeah. So the same algorithm, same thing. If you know the event and it occurs n times, can you predict n plus 1th time when will it occur?
Correct.
That. So you can just answer when, how and where.
Yes. Shashank, thank you very much. We wish you all the very best.
Thank you,
And
man.
we hope that you keep on doing some good work all the time.
Thank you, man. Thanks a lot.
Shashank. Thank you. Yeah.
तो सुना आपने कैसे हेल्पिंग फेसलेस प्रोजेक्ट में टेक्नोलॉजी और मैथमेटिक्स यूज करके एक एंड्रॉइड ऐप क्रिएट किया गया है। शशांक सिंह कैसे प्रोबेबिलिटी, डेटा एनालिसिस, सैम्पलिंग, मैट्रिक्स, फेस रिकग्निशन एल्गोरिथम्स जैसे मैथ कॉन्सेप्ट्स यूज करके बच्चों की मदद करना चाहते हैं।
a plus b the whole square is equal to a square plus b square plus 2ab. A plus b the whole square is equal to a square plus b square plus 2ab. A plus b the whole cube is equal to a cube plus b cube plus 3ab plus a plus b the whole cube is equal to a cube plus b cube plus 3ab plus a plus b. Forget it, I'll do some other only some math. A upon b divided by c upon d. No. A upon b upon c upon d is equal to a upon d into, oh god, a upon b upon c upon d. A upon b.
Arey Buddhu, it's a upon b upon c upon d is equal to a upon b divided by c upon d is equal to a upon b into d upon c is equal to ad upon bc.
Oh my god, take a breath. How do you know so much?
अरे मैथ्स ऑन रेडियो ने सिखाया। मैथ्स ऑन रेडियो नहीं सुना क्या?
मैथ्स ऑन रेडियो?
हाँ, अब सुनिए मैथ्स ऑन रेडियो हर रोज सुबह 9 बजे, दोपहर 1 बजे और शाम 7 बजे ओनली ऑन 107.8 मस्त रेडियो।
मैथ्स ऑन रेडियो लगाओ, दिमाग की बत्ती जलाओ।
The definition of derivatives goes this way. The derivative of a function of a real variable measures the sensitivity to change of a quantity which is determined by another quantity. Don't worry friends, though the definition sounds so abstract, we use a lot of derivatives in our daily life. To know more about how we use these derivatives in our daily life, let's listen to Sushil Torne. He is a research fellow at the Department of Economics at the University of Mumbai.
Hello friends, welcome back to Maths on Radio. I'm Pankaj and with me my friend Sushil is there. Sushil, in this Maths on Radio program, we try to talk about maths, but I'm really not sure that do we really use mathematics in daily life?
Like we are here today to talk about calculus.
Calculus?
Yes, and I think we use calculus in our daily life.
What do you mean? Calculus, of course I've learnt it in school, college and my engineering days, but how do we use it in daily life? I thought it was just theory and theory and theory.
Pankaj, what's the time right now?
It's 25 minutes past 3 o'clock.
So 25 minutes. Can you tell me the spelling of minutes?
M-I-N-U-T-E-S.
And can you tell me the spelling of minutes?
M-I-N-U-T-E-S.
So why do we say minutes and minutes? What's the difference?
Minutes probably are for time and minutes are for maybe a meeting.
Okay, so now when the time is 3 minutes, 23 hours and 25 minutes, it means that with respect to the whole day,
right,
it's 3 hours and there are 25 minute parts of the third hour. And how many seconds are there right now?
About 30.
So why do we say seconds?
Because that's the unit after minute, so 60 seconds make a minute, that's why.
So when you say 3 hours, 25 minutes and 30 seconds, we are giving 3 hours, 25 minutes are 25 minute parts of the 3 hours, which means it's a first order derivative, and the second order derivative is 30 seconds. So second got a name from the second order derivative of the hours.
Oh, so that's why we say, but then do you call it minutes or minutes?
It's minute. Our forefathers said minutes, but evolution and how, not evolution, but we evolved saying in minutes.
So the actual use of the word or pronunciation is minutes.
Minutes.
3 hours and these minute parts of an hour.
Yes, and then the second order derivative of the 3 hour becomes the second.
And that's why we say 10 seconds, 20 seconds, 30
exactly,
seconds.
That's a second order derivative of an hour.
That means
so we calculate everything with respect to hour, because this is what our forefathers said, like forefathers did.
Oh, so we use it in everyday life and
exactly.
Still we don't know its importance.
Exactly, and by the way, this is the method which I'm talking right now is the Lebesgue method.
Lebesgue method?
Yes, because there are two methods. One is a Newton method and second is a Lebesgue method.
Okay.
So in Newton method, normally the Englishmen, they say, like 3 o'clock.
Oh.
So when they say 3 o'clock, O means a 0.
Okay.
So when the shorthand is on third and the big hand is on 12, the 12 hand which is on 12, the slope is counted as 0. That's a geometric method of saying 3 o'clock.
That means it's 3
I'm counting the slope as O, which is 0, and it's clock.
This is amazing. I mean, we look at the watch almost at least 10 to 15 times in a day, but we probably don't understand the background behind it. It's all mathematics.
It's all mathematics. It's basically derivatives, and it's basically calculus. Calculus is like a minute change, a very minute change with respect to an hour. But to tell you to be very frank, it's all relative.
It's all relative.
Yeah, because if you say, because the thumb rule is an hour is counted out. But if you are a physicist, then you'll say you'll count the microseconds, and so the second order derivative would be of some pectoseconds, or some nanoseconds. So that's again relative. But in normal terms, normally we use these kind of frameworks.
So it's minutes, and it has now become minutes.
Yes.
And it's seconds because it's the second order
derivative
of the hour. And that's why you say so many seconds.
Yes.
So 60 seconds make up a minute, which is known as a minute now.
Yes.
60 minutes or 60 minutes make an hour.
Yes.
And 24 hours make a day.
Yes. And to be very precise in calculus terms, I would say 1 minute.
To be precise.
To be precise.
So it's simple.
And then 1 second would be 1 upon 36,000 parts of an hour.
Yes, because 60
Sorry, 3,600.
Yes, 3,600. That's right.
Yeah.
So 1 hour is 60 minutes.
Yes.
1 minute is 60 seconds.
Yes.
So an hour is 60 into 60.
Yes.
That's 3,600.
So 3,600
parts.
Minutes and minute parts, second minute parts of an hour.
So it's not actually difficult, you know. So why do you think people are so confused? Only because of the language. Probably they don't understand. As you said, there's the Newtonian method. The Britishers would say 3 o'clock, and
this is basically the German method,
Leibniz method.
Yeah.
So is it only because the language weighs on you, and we don't understand simple logic of the mathematics?
Yes, because we have taught to understand language of mathematics in symbols, and these symbols are universal. So if I write a mathematical paper right now, so people, even if I write say German, and another mathematician from other part of the world reads the equation, he understands it.
Exactly.
So that's basically a language. So we should see maths as a language.
Exactly. So probably we can also say that mathematics is one of the most common languages across the whole world.
Yes, it's a universal language.
Absolutely. Stay tuned to more maths updates on 107.8 FM.
फिर से मैथ्स में 0। हे भगवान, कब बनेगी तू मैथ्स का हीरो? क्या करूं मैं इस लड़की का?
अरे ट्यूटोरियल ज्वाइन करवा दो।
अरे नहीं, एजुकेशनल क्लासेस।
नहीं, प्रीति मैम की नोट से ही पढ़ लो।
नो मॉम, अब मैं करूंगी मैथ्स में टॉप और उड़ाऊंगी आपके होश, क्योंकि बढ़ रहा है मेरा जोश। अब नहीं देंगे हम मैथ्स टीचर को दोष, बिकॉज मैथ्स ऑन रेडियो हर रोज सिर्फ और सिर्फ 107.8 मस्त FM पर, सुबह 9 बजे, दोपहर 1 बजे और शाम 7 बजे।
अगर कोई चार्टर्ड अकाउंटेंट फिल्म निर्माण करता तो उसकी फिल्मों के नाम कुछ इस तरह से होते। मुन्ना भाई सीए, हमारा लेजर आपके पास है, जर्नल से बैलेंस शीट तक, कभी क्रेडिट कभी डेबिट, हम टैक्स दे चुके सनम, मैंने ऑडिट किया, क्यों टैली हो गया ना। जब जब डिस्काउंट मिले, बिल है के पास होता नहीं, बैलेंस शीट की कसम, क्या यही क्रेडिट पीरियड है? हम हैं अकाउंटेंट बेकार के।
इसी तरह हंसी मजाक के थ्रू हम आप तक मैथ के बारे में इंफोटेनमेंट पहुंचाते रहेंगे ओनली ऑन आवर शो मैथ ऑन रेडियो सीजन 2। तो लिसनर्स, हमारे काफी सारे दोस्तों को मैथ्स पसंद नहीं है। देखते हैं उनका क्या कहना है मैथ के बारे में।
पूजा अग्रवाल and I am studying in Wilfred Law College. And I love maths because it is very tricky and it is easy, very interesting to solve.
So since you love maths, can you tell us what is the most important thing when a student has to love maths?
He has to know about the calculations and all.
And what is the role of a teacher in this?
Make the children learn the new innovative methods and techniques so that maths become very easy for them. Actually, maths is a havoc for children ki kaise karna hai, kaise hoga. तो एक अच्छी टेक्निक अगर उन्हें सिखाई जाए और इजी से बताया जाए तो इट बिकम्स वेरी इजी।
ओके, और आपको क्या लगता है क्यों यूजुअली बच्चों को मैथ्स पसंद नहीं होता, या व्हाई इज इट अ हैवॉक फॉर देम?
क्योंकि उसमें बहुत सारे फॉर्मूलाज होते हैं और कभी मैथ्स में कुछ लॉजिक ऐसे होते हैं जो समझ में नहीं आ पाते हैं, इसीलिए।
तो आपको लगता है कि वो सारे लॉजिक जो समझ में नहीं आ पाते वैसे होते हैं, उनको समझाया जा सकता है अगर अच्छी तरह से सिखाया जाए?
ऑब्वियसली।
मेरा नाम उत्कर्ष सोनावे है, मैं करजत में रहती हूँ। मैं सेंट विल्फ्रेड कॉलेज ऑफ लॉ पनवेल BLS फर्स्ट ईयर में पढ़ती हूँ और मेरे को मैथ्स अच्छा नहीं लगता बिकॉज मेरे को समझता नहीं वो प्रॉब्लम सॉल्व करने की स्टेप मेरे को याद नहीं रहती, मेरे को नहीं अच्छा लगता।
My name is Surbhi. Okay, I came from Mumbai and I don't like maths because it's annoying and it's irritating. Maybe because maths को रट्टा नहीं मार सकते, समझना पड़ता है, maybe that's why.
सुरेश, आज मुझे हिस्ट्री आती है, ज्योग्राफी आती है, साइंस आती है, केमिस्ट्री आती है, फिजिक्स आती है, तुम्हें क्या आता है? हाय
भाई मुझे मैथ्स आती है भाई।
तूने मैथ्स कहाँ से सीख ली? हाय
अरे अब मैथ्स सीखना हो गया है आसान। मैथ्स ऑन रेडियो सिर्फ 107.8 मस्त FM पर सुबह 9 बजे, दोपहर 1 बजे और शाम को 7 बजे। मस्त सुनो और मस्त रहो।
So in our today's episode on Math on Radio Season 2, we heard how probability, data analysis, sampling, matrix and face recognition algorithms can be used for a social cause too. We heard from Shashank Singh how an Android application can be created with the help of technology and mathematics. We also heard about derivations. Though they might sound like a complex concept, we use them a lot in our day-to-day life. And so Math on Radio Season 2 is here to simplify all such complex math concepts for you. I'm sure you liked our today's show, so do send us a feedback on our email ID radiomust@gmail.com. That is radiomust@gmail.com. And do like our Facebook page for our regular updates. Also, listen to the episode podcast on our website www.mustradio.in, which is www.mustradio.in. So this is RJ Priyal on Math on Radio Season 2, only on 107.8 FM Must Radio, where you get your daily dose of infotainment.
अयो वेणुगोपाल, मुझको बता कि अगर प्रसाद अन्ना के पास 10 चॉकलेट और 10 रसगुल्ले है और अगर उसमें से वो 9 चॉकलेट और 7 रसगुल्ले खा लेता है तो उसके पास क्या है रे? डायबिटीज। अयो वेणुगोपाल, उसका आंसर है 1 चॉकलेट और 3 रसगुल्ला। तेरे को तो बिल्कुल नहीं आता रे मैथ्स। अब मैं क्या करूँ अन्ना? अरे मस्त FM सुनने का ना रे, 107.8 मस्त FM फिर सुबह 9 बजे, दोपहर 1 बजे और शाम को 7 बजे मैथ्स ऑन रेडियो आता है रे, वो तेरे को 100% सिखा देंगे।
நீங்க கேட்டுக்கொண்டிருப்பது மும்பை பல்கலைக்கழகம் மாணவர் ஒலிபரப்பு ரேடியோ மஸ்ட் 107.8 FM.
दोस्तों, आज के लिए बस इतना ही। मैथ्स से जुड़ी जानकारियों के लिए सुनते रहिए हमारा प्रोग्राम मैथ्स ऑन रेडियो। अगर आप भी मैथ्स के बारे में कुछ जानना चाहते हैं या फिर हमें कुछ बताना चाहते हैं तो तरीका बहुत ही आसान है। आप हमें ईमेल कर सकते हैं radiomust@gmail.com पे, या फिर आप लॉग इन कर सकते हैं हमारे फेसबुक पेज पर mathsonradio@must. Till then, take care.
This is Must Radio, only on 107.8 FM.
Maths on Radio, a program catalyzed and supported by National Council for Science and Technology Communication, Department of Science and Technology, New Delhi.